So, hi everyone, and welcome to the latest Biome podcast with Emma and Robi. And this week we are really lucky to be joined by Tom Ovenden, who is a PhD researcher in Forest Ecology and Resilience at the University of Stirling in Scotland. And he's also done some incredible work in sort of forest management, working with the Scottish Wildlife Trust as well, and was also a biosecurity ranger in New Zealand. And he's also carried out this incredible master's project about Lynx reintroduction to Scotland. And kind of this is what we will be talking with him about today. So thanks so much. Welcome to the podcast, Tom. We really appreciate you talking to us. So obviously that was a very brief overview of the incredible things that you've done. Is there anything you want to add about your work and kind of and what you're doing?
No, I think that's a wonderful introduction. Thanks very much, Emma. Just looking forward to talking about it. Like most scientists, everybody enjoys being given the opportunity to have a bit of a chat about what they've been involved in. So yeah, no, quite happy to dive right in if you'd like me to just give a bit of an overview of sort of what we did, if that would be useful.
That'd be great. Thank you.
So this was, as you said, this was my master's project. So I think this was 2017. I lose track of time. So originally, this kind of my master's actually was environmental forestry, and so there's a very sort of fairly tenuous link to forestry, I think, with this project. But I've kind of had a big interest in applied research and wanted to do something that really had the potential to have a real world impact, or have sort of contribute some meaningful evidence to a current debate. And so it was fair to say that when I came across this sort of this topic, it was already fairly polarized. Everybody had an opinion, and their opinion seemed to be fairly divided. And so doing a little bit of general reading as I was trying to decide what project to get involved with for my master's dissertation, kind of became aware that a lot of the existing literature on the subject, so that the sort of foundational literature in Scotland was by a chap called David Hetherington as part of his PhD thesis, and that sort of set the foundation upon which the discussion was being had. And I just kind of noticed that some of the data sets that had been used, while appropriate at the time, were now slightly outdated. And it kind of struck me that, considering how dynamic landscapes are sort of this day and age, and how much sort of ecological modelling and ecological theory develops, it would be interesting to see whether we could sort of effectively revisit that original work of David's and see whether whether it's sort of still not held up so much to speak, but whether contemporary landscape data that we had available, sort of more sort of contemporary distributions and resolution of habitat data, and new modelling tools that had become available that incorporated these developments in ecological theory could be sort of deployed in this sort of setting of trying to provide a bit of evidence as to whether there was any kind of ecological sort of basis upon which you could reintroduce Lynx to the UK. So it had all the hallmarks of a nice project, and so that was what I ended up doing. Sort of slightly ambitiously did it whilst doing a full-time job on a remote island I was running for the Scottish Wildlife Trust at the time so it was a slightly funny situation where we had only solar panels, and so I could either have the laptop charging or use the modem to download papers. So we kind of ended up switching between the two, but it was quite a nice place to do it. So yeah, it was amazing. I've got a great picture of me writing my thesis with the view out from the island, which is sort of, I need to get it framed somewhere actually.
That's fantastic.
So the modelling software I kind of, again, just sort of came across by chance really, and it was developed by colleagues up at Aberdeen University. And the modelling software itself is called Reinshifter. And the idea behind Reinshifter is it's sort of spatially explicit, so it takes into account sort of landscape maps that you can feed into it. And it models the dispersal and movement of species based on parameters that you put in the model across those landscapes. And so it just struck me that that was a perfect tool for answering this kind of reintroduction question, right? So we could feed in a landscape map, sort of an actual map of the habitat distribution and sort of abundance across Scotland, or any landscape really. And then we could take all the existing literature on this particular species, feed it all in together effectively, and then model and sort of different sort of reintroduction scenarios to see what might be a good place to do it, what might not be a good place to do it, or just to kind of get an idea of whether it was feasible at all. And so, in a nutshell, that's pretty much what we did.
So what was, in terms of, you were looking at, Lynx distribution, what was the end goal of this fantastic project?
So from my perspective, there was two. The first was to do a master's project and actually graduate. And the second one was really just to see whether the sort of most sophisticated tools that we have at the time and the most sophisticated, sort of the most up-to-date habitat distribution maps that we have across the UK, coupled with all of this sort of rich body of literature on lynx ecology, if we brought all that together, to model as realistically as is currently possible to simulate sort of a reintroduction and how individuals would move across the landscape, how much populations would grow, when individuals would die, all that kind of stuff, whether at the end of the day it gave us any indication of whether it's actually even possible to have a functioning population after a reasonably long period had elapsed. So the core question, I suppose, was just to sort of bring all of this together, as ask that question: if we were to do it, would it sort of, is there any way that it would result in a stable population in the long term? And if so, where might be the best place to look to do it?
And that's really interesting, because I stumbled across what kind of really struck me about your work. I was going through YouTube and I was looking at, I think, wolves, and then I stumbled across your fantastic YouTube video with the Scottish Wildlife Trust, which was great. And I very excitedly messaged Emma and I was like, we've got to talk to this guy because he's done this really cool thing on lynx. But the thing I really liked about it, which I hadn't seen so often in other kind of reintroduction debates, was the fact that you looked at over 100 years, will they survive? Because it's very easy to say, yeah, we're going to bring some lynx in, but you kind of miss the point, I think, if you don't know whether those lynx are going to survive for any meaningful length of time. So what were the findings at the end of this fantastic project?
So that's a really good point. And I think that's both a strength and a caveat to our study, mm-hmm. And any study looking at that kind of duration, I would say. So with sort of, especially with reintroductions of like large carnivores, it takes a really long time to really know if it's been successful or not. And so, as you quite rightly say, you need to be looking over a much longer time horizon than maybe 5 or 10 years, particularly as, in order to reach a kind of genetically viable population level, a number of sort of individuals in your population, it just takes time to accrue that number of individuals in your population, right? And so the caveat that I would add is that, of course, when you're modeling or forecasting or estimating that far in the future, the further away you get from now, the more uncertainty there is about how representative your results are going to be. And so while we looked that far ahead because it's appropriate to do so, we do have to take all the results with a pinch of salt, because partly, of course, the landscapes of 100 years are not going to be the same as the landscapes of today. And so when we're talking about the functional connectivity of landscapes and their suitability for reintroduction, obviously that plays a big role, which was one of our kind of arguments in the first place. But from a what we found perspective, so we sort of decided to look at 3 key sites, and those sites weren't identified by us. We picked them from the literature as already having been sort of earmarked, I suppose you would say, by other organisations to say these might be candidate sites. So they were sort of a good place to start, I would say, for us. So we looked at 3 potential reintroduction sites, one at Kielder Forest, one on the Kintyre Peninsula, which is the west coast of Scotland. Kielder Forest is on the border with England, and then Aberdeenshire, which is kind of on the east coast. So there was quite a nice geographic spread as well. And then we also did a bit of sort of subsequent modelling where, rather than just looking at one site, we looked at what happens if you split the population and introduce some at one site and some at another site simultaneously. Really what we found was a clear, I suppose we termed it a hierarchy of suitability, which is just a fancy way of saying some places were consistently good and other places were consistently rubbish. And so the Kielder Forest site was what was probably most interesting, I suppose, in a sense, was that's been the focus of a lot of recent debate about whether a trial reintroduction should go ahead there. And we found that was the least suitable site of all 3 that we tested. Aberdeenshire,
that's interesting.
Yeah, I mean, that's what we thought too. And I mean, I can go into that in a bit more detail if you'd like.
Well, yeah, because a lot of the literature around reintroduction, especially with the lynx, Kielder Forest pops up, and I think there was an attempted thing where people really thought quite hard about it. So,
because wasn't there a proposal to Natural England for Kielder Forest? Because I know Robi and I have talked about Lynx quite a lot, and that's the one that we kind of discussed that has been talked about so much. Whereas something like the Kintyre Peninsula, I hadn't even heard of that as a site.
So I'm trying to figure out the best way to ask this question. What was it about Kielder Forest, do you think, which made it less suitable? And what about, for instance, Kintyre and Aberdeenshire, which had higher success values? What made them better? Like, what's the kind of parameters for success with this?
Yeah, great question. And I think that really gets at the heart of what the modelling that we were implementing was able to kind of to get at, I suppose. So one thing that's worth saying as well initially is that we defined the border, if you like, as a very strict border. So we didn't include the English component of Kielder Forest. So Kielder Forest is bigger, it straddles the border, but we had to put a boundary somewhere, basically. We decided not to use the whole of the UK because it was a logistical thing. So I would have had to have done all the habitat mapping for the whole of the UK, not just Scotland. And there's a time limit with a master's project. So we chose the political boundary, if you like. And in some ways that reflects the devolution of sort of environmental policy to government in Scotland. But anyway, Kielder Forest is geographically in the southern uplands of Scotland, whereas the Kintyre Peninsula is on the west coast, and Aberdeenshire, as I mentioned previously, is on the east coast. And in between sort of those, the Aberdeenshire site and the Kintyre site up north, if you like, and the Kielder Forest site down south, is what's called the Central Belt in Scotland. And that's basically Glasgow on the left and Edinburgh on the right. And so those two cities and the roads that sort of link the two, and the rail networks and everything, and the population density, so they're the two highest population densities in Scotland at the narrowest point in Scotland, pretty much. And so what I'm kind of getting at here is that when we modelled a reintroduction, either from the sites at the top or in sort of Kintyre or Aberdeenshire, or at the site at the bottom in Kielder, is that we found that almost never, no matter which site we reintroduced it from, did Lynx manage to cross that sort of boundary of the Central Belt and disperse into habitat in the north or habitat in the south. And so this kind of, I think, starts to get at a really good point, I think, which is sometimes raised and sometimes missed, where it's not just the amount of habitat you have, it's how functionally connected that habitat is from the perspective of the species being considered, right? And so I think what probably was happening was that we were reintroducing, when we were modelling reintroduction from Kielder Forest, is that they were able to sort of disperse and colonise all of the sort of suitable habitats south of the Central Belt, but they were never able to expand into all of that suitable habitat, of which the majority is above the Central Belt. And similarly, when we were reintroducing them to sort of either the Aberdeenshire site or the Kintyre site in the north, they were able to sort of spread across the northern section of the landscape, but never really able to colonise the southerly section. And just there is more habitat north of the Central Belt, suitable habitat north of the Central Belt, forest habitat for a lynx. And so the population could spread, it could expand, it could grow a lot more. And I think that's probably why one of the biggest contributing factors, which sort of supported the original work by David, actually.
And sort of interesting point you made there about the connectivity of landscapes. Do you think that sort of if more efforts were put in place to maybe, I don't know, have more things like wildlife corridors, like they've done for other big cats, say jaguars in Costa Rica and things like that, would that change your model, do you think, if there was more consideration of wildlife corridors?
It's possible, yeah, certainly. The problem is the kind of granularity of what you're able to model. So, for example, we were able, because roads in Europe are kind of definitely linked to higher rates of mortality in lynx, so we were able to effectively include a higher kind of mortality probability, if you like, for roads within our landscape map when we modelled it. But of course, that's just an estimate. And realistically, you know, they could be higher, they could be lower. They might be more localized in one place, slightly lower in the other. You know, rural roads are probably less likely to be as bad as major motorways, which we did capture to a degree, but it's still applying just a single parameter value for large roads and saying that represents a chance of mortality of X, Y, or Z. And so it would be quite hard to model sort of something down to that sort of granularity of saying, well, if we put a tunnel here, then how would that change the probability of a reintroduction success? But that's not to say it's not worth trying. It's just that there's so many variables going on, isn't there? And it's sort of they all have to be taken with a pinch of salt, I think. So yeah, it might work, but I mean, ultimately, if you're trying to plan a reintroduction and you've got one site that you'd have to put in all of this additional infrastructure across the whole of the central belt to even make it potentially viable for a reintroduction, or you've got a reintroduction site that's potentially up north with far more habitat anyway, without so many issues of a high density of really big roads and mortality, the mortality associated with that. You kind of have to weigh up if you were to try and go ahead with it, what would be the most sensible place to do it.
And all this kind of mapping that you did as part of this project is incredible to look at, and the detail with which you were able to produce these maps. And obviously, it's really heartening to know that there is a scientific basis for this. But one of the reasons, you can't just say, we need lynx back. You've got to give a reason, and a reason that's tossed about quite a lot is grazing pressure, and how introducing a large carnivore might alleviate grazing pressure in parts of Scotland. And me and Emma are really all for lynx reintroduction. So we've been guilty of coming out and saying, yeah, stick a load of lynx in that'll take the deer population down. But another thing I noticed in your work, which I thought was really interesting, was you talked about how the lynx is such a roe deer specialist that the effects of alleviating grazing pressure might not be evenly spread between all the deer in Scotland, which I thought hasn't really been talked about that much. So do you think that actually a bit more is being made of this grazing pressure reduction, ecology of fear, than might actually occur if you did bring them back?
Yeah, so I think in my honest opinion, this is an area that's often glossed over and not given enough voice in debates. And as you mentioned earlier, I think it's really important to be open to having a measured debate about all of the collective evidence suggests. And I think in my opinion, I think we're asking the wrong question. Fundamentally, we're asking the wrong question of rather should we do it? I think it's almost one's question too far away already. So I think for me, the first question from a scientific perspective is there sufficient evidence to make an informed decision? And I think the answer to that question is no, from multiple angles. So one, for example, we don't have the sort of sociological information. There haven't been enough consultation, but equally, we don't know, nobody's done any calculations to my knowledge as to what the impact on roe deer would be. So there's it is true that they're roe deer specialists, and it's almost certain that they would have an impact, but it's not necessarily just having an impact that's important, it's the scale of that impact, right? And so as you said, because they're roe deer specialists, what would the impact on red deer be? So from a predation perspective, probably very, very low. And the reason we think it will be very low is because other studies in Europe, for example, have found that they basically don't take red deer. There would be the very occasional red deer. We're talking maybe 1 or 2 in 1,000, I think, was the piece of literature I read.
And I imagine those would be calves. Those would be quite young, because Emma and I have spent some time filming red deer this autumn, and the big males. There's no way a lynx could. Maybe if it was a really tough lynx, it might get away with it, but I don't think it could bring one down.
Exactly, yeah. And I think this is the point, right? So they're just too big, and as you say, they might get the odd sort of young one, but realistically, why would they attempt to take down a red deer when there's an abundance of roe deer, which is their preferred prey species anyway? Probably partly because of a roe deer's size. And so yes, what that question remains, I think, and it's one that needs to be answered, of what would the likely impact of a lynx reintroduction be on populations of roe deer, or the population growth rate of roe deer. And I think the thing to factor into that is, even if you reintroduce lynx now, we discussed a second ago that obviously the population size of lynx takes time to grow. And so the impact on any population of roe deer, there would be a lag. And so I don't, to my knowledge, and it's always something I've meant to do actually, but I've not even heard of a back of the fag packet, so to speak, calculation to say, okay, well, if lynx hunt X number of roe deer and we have X number of lynx, and the population growth rate of lynx is this many per year, so we can multiply that together and say, well, they're likely to take, with a certain amount of confidence, this many roe deer. And then, for example, say, well, if that's how many roe deer they're expected to take in a given year, and this is how we expect that to change over time, what's that in comparison to the current growth rate of roe deer? So
that's fascinating.
So that's not something that's been done then, to your knowledge. Okay.
No, not to my knowledge, and it's something that I'm really keen to do actually, as the next logical step from the ecological side. Whereas obviously other parallel work fundamentally needs to be done from the social side to understand what people's concerns are, and maybe we'll touch on that later. But yes, so there's undeniable that the impact there would be an impact on roe deer, I think, because they're their preferred prey species. So you introduce a carnivore, and you're introducing a functional process to that ecosystem that's missing. So there would be an impact, but the scale of that impact on that one particular species would change over time. That would itself be dependent on the location of prey and the location of lynx and the population growth rate of the two species, amongst other things. And nobody really seems to acknowledge, as often as I would like to see, that the impact on red deer would be, certainly from a predation rate, be negligible. And so there's obviously other conversations about the behavioural impact there, which again, maybe we'll discuss in a bit. But yeah, so in answer to your question, I don't think there's any evidence to suggest what the impact would be. It is assumed that there would be a meaningful impact. But of course, meaningful is different to different people.
Yeah, and I guess if hypothetically you've got lynx in the environment and they're only taking roe deer, does the whole you hear about an ecology of fear quite a lot in Reintroduction. I think it was that concept was kind of coined in reference to Yellowstone and the wolves, but does an ecology of fear trickle down and cross species even if there's no predation there? I think that's probably an area for further research as well.
Yeah, I mean, I think one of the key arguments, which I think is a very valid one from an ecological perspective, is that we're currently missing top order predators in this ecosystem. So again, that has to be caveated by this ecosystem is different now, very different, as is the landscape from when they were here previously. So it has to sort of all be considered within that context. But I think one of the arguments for reintroducing them is to restore a functional process in that ecosystem that's currently missing. And that does have downstream consequences, so-called sort of trophic cascades, I think is the official term. And so this sort of, you implement something or something happens at one area of the food chain and you get a sort of cascade of implications all the way down the food chain. And so what that would look like is completely open to interpretation. I mean, we can hazard a good guess, I think, based on, similar studies of the same species and other systems and what kind of happened there. But ultimately, we'll never know until we do something. We can only estimate what we think the implications will be. And it's very, very important, coming back to that evidence perspective, of asking that first question: do we have enough evidence to be reasonably confident about what the most likely alternative pathways would be if a reintroduction occurred? And Scotland's in a very strong place for that. So we've sort of developed the Scottish Code for Conservation Translocations, and there's a bit of a world leader in that. And there's quite a lot of experience. So, there are statutory and non-statutory processes in place to make sure it's done properly. And a lot of those obviously feed off of what I'm saying. Is there enough evidence to really suggest that we know, if it's feasible or if it's the right thing to do, or no?
Because then I think also, like, from that ecological perspective, sort of similar in relation to the roe deer and the ecology of fear, is that the mesopredator control argument that is often used, that they might be able to suppress things like fox numbers or even possibly wildcats or things like that. But then it's like, well, if lynx are kind of mesopredators themselves, are they going to have as much of an impact on controlling fox numbers as, say, something like wolves would? I don't know if that's something that you feel is almost over-exaggerated in a way of, like, the effects that they would have on kind of fox numbers or even wildcats or things like that.
I think it comes back to this question again about, do we have any evidence of what the impact might be? And to my knowledge, nobody's tried to estimate what the impact on fox numbers would be. So it's is it just conjecture? I mean, again, there would likely be an impact because they do kill foxes. And so but the quantity, again, it comes down to how many foxes would they kill and how many foxes are in the area that the lynx are in, and how does that relationship change over time? Because these, all the ecological systems are dynamic, so there's constant change, and we can sort of estimate what we think might happen based on what we know, but ultimately different things will emerge over time, some of them unforeseen, as has been the case throughout history with some with some efforts in different countries. But the impact on mesopredators on that point, so there's, as far as I'm aware, risk of maybe oversimplifying it a little bit, but there's sort of direct and indirect impacts, right? So there might be the direct predation risk of foxes, but they also might hunt the prey that the foxes are hunting. And so how do those things interact? What's the kind of additive effect of potential reductions in the prey of the fox at the same time as predation on the fox on fox numbers, if that makes sense. And I don't think we really know. And it would be very hard to know, I think, until it happens. But we can only try to, this is where the value of modelling comes in, I think, because it gives us some idea based on ecological theory and sort of the ecology of the relevant species.
And to come to that, very accurate point that sometimes you just don't know, and there are always unforeseen things that pop up. On the kind of social side, there was an introduction in Switzerland where there wasn't enough consultation with the landowners or farmers, and they had a number of lynx being killed. So kind of on that social side of it, but bringing in a bit of the ecology, you've got lynx livestock conflict to consider with any reintroduction. In Scotland, and a lot is made of numbers coming out of Norway about predation of lynx on sheep, because a sheep is kind of red deer sized, and I imagine they're quite easy prey. But you mentioned in your video that you thought that there might be a way that lynx in Scotland would behave around livestock differently or interact with livestock differently to Norway, about Norwegian grazing practices where they usually graze in woodland, whereas Scotland, most sheep grazing is hillside. So on the social side of it, but bringing in that ecological behaviour, do you think there is a credible threat to livestock if you did bring the lynx back?
So the short answer is, yes, there is a risk. Of course there is a risk. Because sheep are predated in Europe by lynx, so it would be unreasonable to suggest that there was no risk. And I think this is where the social component is just absolutely fundamental. And people's concerns, even if other people might think they're unjustified or not founded in sort of evidence, need to be heard. Because I mean, it has been said that people are the most important aspect of any reintroduction, so getting people on board. I'm not sure I necessarily agree to ascribe an importance of most importance to one particular aspect, because from my view, you could have all of the social appetite in the world, but if you don't have the habitat, then it's not going to work. In the same way, you could have all the habitat in the world, but if you don't have the social appetite, then persecution risk is high, and that could also cause a failure. So it's a kind of it's the integration of all of those aspects collectively that needs to inform a decision on this. So the differences, that comment that you're referring to about differences between maybe European systems and that in the UK is partly informed by how we graze sheep, as you mentioned, in Scotland or the UK, and how they're grazed sometimes in other countries. I don't profess to be an expert in Norwegian sheep grazing practices.
That's fair enough, we'll let you off.
That's good of you. So I have heard that there is more grazing in sort of forest habitat and sort of the woodland sort of setting. That's where I think context really is king. Because if we think about how lynx, the ecology of the lynx, like how it hunts its prey, and it's an ambush predator. And it's a woodland ambush predator, which is why we modelled our reintroduction at woodland habitat. It requires woodland habitat, albeit different types of woodland for different bits of its life stages. So, some bits are better for hunting, some bits are better for raising kittens, for example. But ultimately, it needs cover to hunt. That's hence being an ambush predator. So if you then sort of extrapolate that just a little bit and you sort of think, well, we practice quite a lot of open hill sheep farming in Scotland, like there is arguably limited cover on a lot of that. So it would possibly be a lot harder for a lynx to catch a sheep on an open hill farm without any cover than it would be to catch a roe deer, its preferred prey, in its natural habitat. So
that's interesting.
I think if you just sort of think about these things in the context of the ecology of the species, you start to realize that there are some key differences there. But that's not to say that there would be no risk. And I think this is where the polarity of the debate kind of gets it a little bit wrong. You can't say there's no risk, but you can't also say that there's going to be, we're certain that there's going to be a massacre of loads of sheep, because those differences need to be taken into account. But, again, it comes back to this idea of, but we haven't reintroduced lynx to Scotland yet. And so there are always going to be uncertainties, but the key to those uncertainties, and at least during discussions, is to make sure that everybody's heard in a respectful debate. Mm-hmm. And if people are heard, then and information is shared openly and freely, and people are willing to listen to each other's point of view, then I think a respectful dialogue can be started. And that's when, for example, you start to find solutions to these potential problems and compromises from both sides. So, for example, in Europe, they have compensatory mechanisms in particular places which are not without their own problems, without going into specifics, but those mechanisms exist and they are in place, and they're designed to make sure that it's not just conservationists of one particular opinion getting one view, or farmers of one particular view getting one opinion. And my last point on that, I think it's also quite dangerous to say that farmers think this and conservationists think that. Siloing groups of people with one single opinion is also fraught with danger, in my opinion, because there's a lot of people, I think, from both sides that are willing to acknowledge that there are things that need to be sorted out, and they're willing to have a debate about it. And we can't just assume that everybody is of a particular opinion.
I mean, we've talked about that. We fully agree. We've talked about that so much with any conservation or reintroductions. It's like you need to have the people involved, of like all stakeholders, if you are to make progress. Because when we did a podcast about lynx previously, and had sort of, like you were saying with the sort of livestock solutions, some of the things that we talked about were those kind of the compensation schemes, and how in places like Scandinavia you have sort of compensation for even having dangerous predators living alongside the people. It doesn't even have to be a direct sort of predation. And then there was, Robi, do you want to explain? There was another unusual solution.
This was our favourite one.
We're curious what you think of this one.
Yeah, so as someone who's, read I assume read a lot of literature on lynx behaviour, what do you think of guard llamas? Because we think it's a great idea, and it's worked in the US with reducing sheep predation by coyotes. So essentially, you have a guard llama that grazes with your flock, and I think I've been spat and bitten at by a llama once or twice. It was not that pleasant, and so the idea is this llama essentially patrols and sees off mid-level predators like foxes and lynx. So that's one of the more creative solutions we've come across in our exploration of lynx reintroduction.
I have seen this in the mainstream news. I think this being suggested. Where to start? So of course, creative problem solving is a good thing, and if it helps people to engage in, as I said, respectful debate about finding ways around things so that everybody makes a compromise and it resolves an issue, then that's got to be a good thing. Of course, with anything like this, you would need to establish it's sort of viable. So for example, in your example, lynx and coyotes maybe don't behave the same, so therefore would, just because it works in one place with one species doesn't necessarily mean that if we bring that same approach and put it in a different setting with different, in a different landscape with different key players, if you like, then there's no guarantee that would work. And then there's all the kind of logistical things. So where are you going to get that many from? Was it llamas or alpacas?
I think it's llamas they're using. Llamas, because they're quite big llamas, aren't they?
And what's the impact of introducing probably thousands of llamas to the UK, for example? I guess I don't know anything about llamas, I'll be honest. I guess they would also just graze, but who's going to, where are they coming from? Who's going to pay for that? What are their impact on the landscape? will it even work? So yeah, I mean, I suppose it's an interesting anecdote. I'm not sure whether it would work or not. I don't think there's. I don't know.
I mean, yeah, that was definitely one of the more alternative solutions that we came across. But I guess in terms of, so if we're talking about lynx and the feasibility that they are going to persist long term into the future, say somewhere like the Kintyre Peninsula, in terms of maintaining their populations long term, do you think that could happen naturally, or would they need to be kind of replenished and have like other reintroductions of lynx to subsequently boost the population? Because it was quite varied, wasn't it, in the modelling between the different areas, sort of the output, the final number of lynx that you would get at the end of that.
Yeah, you're quite right, and I think that was one of the. So of all we measured a couple of indicators, if you like, of success, and one of them was how big's your population of lynx after 100 years, and from memory, it was a range of around about 50 in one to 150 in the other, when all of the population started with 10 of equal sex, so 5 female, 5 male. And so, yeah, immediately you can kind of see that a difference in population size after 100 years of 150 or 50 when you started with 10, that's quite a distinct difference.
Yeah.
So I suppose the answer to your question is multifaceted, because there's different elements to why maybe a population would require enrichment. Not all of them I'm sure I'll cover, but so there's a sort of genetic viability component of it. So that will partly depend on the genetic diversity of the sort of stock, if you like, that you start with, or the animals that you start with. That will sort of be propagated throughout the remainder of the population. So you might need to do some sort of genetic enrichment, if you like. Also, of course, there's going to be a period of sort of mortality, possibly, whether that be natural mortality in your founding population or whether that be through persecution, maybe. And so there could also be, especially in the initial stages, and that's why that social component is important to get right, because if you have elevated mortality, particularly when your founding population is low, then of course, you might be doomed, the population might be doomed before it gets off the ground. And so if you, for example, lost a few individuals, particularly if you started to lose a lot of the females, for example, in those sort of early decade, for example, that's an arbitrary period, but it gives a rough idea. Then you might need to obviously bring in more individuals to kind of almost top it up, if you like. And so I think those are the two obvious ones that strike out to me why you might need to sort of increase the number of individuals in the population, or sort of genetic enrichment, or to sort of replace those lost, particularly in the early years. So I think from a genetically viable population in the long term, that was the last thing I was going to mention. Estimates vary, and there are sort of ways of estimating this, some of which, for example, called population viability analyses. And I've seen estimates range from around about 200 to 250, you might think, for a genetically viable population. But, these are estimates and it's not work that I've been involved in. So I'm just sort of quoting other literature that I've seen here, some of which I think was in the context of Scotland. But that kind of gives you an indication of, even in our best modelling scenario, we ended up with 150 after 100 years. And so while that's not to say that there aren't possibly better modelling scenarios out there, or, we only checked 3 locations, for example, it takes time, and this is the thing. And time, of course, particularly with reintroductions, and you can't just reintroduce lynx and then sort of brush your hands and say, that's job done, 100 years later, we'll see how we're doing. That requires constant monitoring. You have to sort of be able to establish, how the individuals are doing. There would probably be things, it costs money, is what I'm saying, as well. So it takes time and resource. And there are interesting arguments about, well, if we have limited conservation funds and we have other habitats in need of sort of attention, or sort of other potentially species from which that are competing for those limited funds, should we say, like, I think the different people will have alternative perspectives as to what the most appropriate use of those funds or resources are. Some people will argue that lynx reintroduction is important because it's establishing that functional process that's missing from an ecosystem and the cascade of other sort of benefits that might be sort of achieved through it. Others might say, red squirrels are where we're at. Let's do the red squirrels. And partly this is all linked, of course, with the issue, in my opinion, of sort of charismatic species get a lot of attention. And are we sort of making decisions based on because we want to see a particular species, or are we making decisions because we're trying to restore or ensure that there are functioning ecosystems working there? And so, is it because it's a lynx, or is it because it's restoring a particular function? Maybe it doesn't matter to you. There's a lot of debate around it.
And that was, you said something really interesting about, in particular with carnivores, you can't just dump them there and walk off. And also it takes a long time. And I think that feeds quite nicely into your earlier point about not generalizing. Like, it's very easy to say, oh, we should bring the lynx back because look, we did it with the beavers and now we've got loads of beavers. But they're clearly two different animals, and beavers, I was about to say they breed like rodents, but they literally are rodents. Anyway, so yeah, I think it's really important, as you say, to actually consider why the lynx in particular. But going back to kind of the modelling aspect of it, you talked earlier about how roads and this big urban belt was really influential in determining, which areas were really successful. Did you find anything to do with actual habitat itself? For instance, what did habitat have an impact on why Kintyre was better than Aberdeenshire or Kielder, or was it mainly the kind of the human aspect of it was the roads nearby, it was the urban areas?
It's quite difficult to sort of pin down. That's a good question, by the way. It's quite difficult to pin down and say, oh, this is exactly why this population was failing. And there is a certain amount of inference that kind of goes on. So, for example, with the fact that there's two huge urban areas, which in our model we were able to. So, sorry, I should go back one step and say that the mapping that we used was incredibly highly sort of spatially resolved. So the resolution was high. So each individual 25 metres by 25 metres across the whole of Scotland was represented by a habitat. So whether that's urban, whether that's freshwater, saltwater, grassland, rocky, forest, and for each of those habitat types, so urban, water, forest, we could sort of ascribe a particular suitability value, if you like. And so that suitability value kind of has a partner, sort of, which is its sort of risk value, if you like. So it means that when we're modelling the movement of a species across a landscape and how it chooses and colonises bits of suitable habitat, we can actually code into the model to say forest is good, lynx like forest, that's good. Saltwater, don't like saltwater, let's stay away from the sea. And so we can take into account how knowledge and literature for how lynx particularly moves across different types of habitat from studies in Europe, for example, and the mortality risk associated with particular habitats, and both include those in the model. So that then enables us to more realistically simulate how a lynx would probably navigate through a landscape, for example. We know, for example, how far we can estimate sort of how far ahead of themselves they kind of know what's coming up. And so that's part of the power of our modelling approach, actually, was that we could sort of say, well, forests are pretty low mortality probability. So if a lynx finds itself in a 25 metre square of forest, then that's a pretty low mortality risk. But if it finds itself on a road, that mortality risk goes really high. And that is the power of that, is that for each individual in the population at every point in time that individual moves through the landscape, all those probabilities are accounted for. And sometimes that means individuals die. Sometimes it means they navigate through the landscape successfully and find a new patch of habitat and set themselves up. So part of the reason that maybe Kintyre might have been slightly better, and again, this is kind of just sort of thinking about what we've seen rather than being able to test it exclusively, but it was a lot more successful than the other sites that we tested. And that might partly be due to the fact that a lot of Kintyre's got a lot of forestry on it, so there's quite a lot of suitable habitat. And the shape of it, if you've ever seen it, it's long and thin. And so it naturally forms a bit of a bottleneck. So the population kind of has to grow, and then it can kind of leave from there, if that makes sense. I mean, it doesn't have to, but it's more likely. And so what might have happened is that it established a stronger founding population, shall we say, from which it could then distribute across a large proportion of the other suitable habitat across the landscape.
So is that a situation where actually, perhaps contrary to what you might think, an actually quite enclosed and quite restricted population, at risk of genetic bottleneck, might actually create a stronger initial founding group which can then disperse out? Does that make sense, or is that just completely bonkers?
It's possible. I suppose maybe the word bottleneck was possibly a little bit poorly used on my part there. So it could just be that I say it's difficult because it is mostly we're just sort of saying, well, this is possible, this is possibly what happened. And the thing with you, once you get out of Kintyre, there is a lot of suitable habitat immediately around you. Mm-hmm. And so it's also possible that the lynx just once, by the time they'd left all of that suitable habitat, because we were also able to code into the model to say, okay, well, there are certain conditions that need to be met for a lynx to be able to call a patch of woodland home, shall we say. And so those conditions might be different for males and females. And so part of that condition to reflect some of the ecology is that if there's too many lynx in one area, then they'll disperse and leave. And so basically what I was sort of getting at with the comment about the Kintyre bottleneck maybe was that Kintyre got full of lynx, and then the lynx were forced to look elsewhere. And so they moved out of the landscape, and maybe they're in that area, there's not really a high density of very busy roads. And so, when we factor all of that in, it could just be that there was a low initial mortality of individuals. And of course, it's worth mentioning that we didn't just run one simulation from each location. We ran hundreds of simulations and then sort of averaged the results to kind of give us a good sample size. And so, this is again, one of the limitations of doing a master's project, I suppose, is that I just ran out of time to look at it in any more detail. So there's so much more that we could do with this model as it's set up now. So, for example, I keep mentioning we only looked at these 3 sites, but it would be perfectly possible to maybe even update the habitat maps again. I think there's even newer data available, so we've got an even more specific sort of contemporary distribution of suitable habitat across the UK. And then, for example, if like the Cairngorms maybe was another place that might be interested because it's got a lot of sufficient habitat, we could then use this model as it's parameterized now, or refine the parameter estimates even better, and then simulate a reintroduction from that site and see how it performed relative to the other sites. So it was kind of, I think what we laid was a foundation, and upon that foundation we can now build, which I'd quite like to see happen, because again, it comes back to just making sure that we've got enough evidence to make a decision. Really.
I think Robi and I, and I'm sure loads of other people as well, have been impressed by is just the scope of the model and kind of how that could be, I think you mentioned, be applied sort of on a wider scale to possibly other reintroductions. But I guess obviously we don't want to take up too much of your time, so maybe the last topic that we could maybe talk about is maybe looking to the future of kind of lynx reintroduction. And sort of in terms of the UK, they're bound by sort of national and international legislation to at least consider reintroducing species that were once native. Do you think that the government has kind of fulfilled its obligation with regards to lynx, or kind of, you mentioned you feel there are pieces of the puzzle missing before we are to make that decision to reintroduce them? What can you kind of see for the future of the lynx and how the government could be involved in that?
As you quite rightly said, there's sort of there's an obligation to consider it, but obviously the word consider does a lot of heavy lifting in that sentence, I think. And part of that consideration will be, to my mind, what is the collective weight of evidence? And that will, of course, be informed by, well, just because it was here before doesn't mean it's necessarily suitable for it to be back here today. And I'm saying that because I like to really give a balanced view of this topic, right? And I think it's important because it's been characterized by polarized opinion, basically. And so I think the remedy to that is to bring sort of rational debate to the conversation, which, in fairness, there is a lot of rational debate too in some circles. So from my position, I think, possibly at risk of repeating myself, is that there isn't enough evidence, particularly from the social side. So, if the beaver reintroduction, anything to teach us is that, these things take really long time and they cannot be rushed. They absolutely cannot afford to be rushed. Otherwise, you start to sort of develop, I don't know, sometimes you have a bit of not quite a one-shot deal, but you kind of got to get it right, and getting it right means engaging people from the beginning. It means respectfully sort of hearing what their concerns are, and then collectively maybe trying to find a way through navigating through that maze. And so there's obviously multiple components that would need to be in place, I think, for a successful application to even be, have a chance, shall we say, if somebody was considering doing it in earnest, which I know there are groups out there that are seriously thinking about this. And so from a science perspective, my question is then, okay, if somebody wants to do this, what's the evidence that needs to be in place in order to make that informed decision? And that's going to be multifaceted. So, of course, you're going to have the social component we spoke about. There's going to need to be some evidence that the ecological suitability of the landscape, which is kind of where we have started to try to contribute a little bit of evidence. Also need to have some kind of indication about what the expected impact on existing species is going to be in the UK. So we've mentioned foxes already, for example. Some people have concerns about wildcat, for example. What, for example, is going to be the likely impact on roe deer numbers? How is that maybe going to have downstream consequences for other species, in the ecosystem? What's the sort of connectivity of landscape suitable for lynx going to be over time? This is another thing that we didn't do, but I would really like to see done in the future, which is to take account of how dynamic landscapes are going into the future. So, forests in the UK, once they are forests, they tend to nowadays not go back so much. And that's partly due to sort of forest policy normally being that if you cut a tree down, you sort of have to replace it. It's quite hard to turn land back over to a different land use from forestry once it is woodland. So we can be reasonably confident that existing forests in one way, shape or form, considering a lot of forests in the UK are obviously managed on a short rotation clear fell system. So how does that factor in, which forests are felled and how does that impact the connectivity of the landscape, for example? But also where are new woodland creation schemes likely to be in the future? What habitats might we expect in different scenarios, maybe, especially with the drive towards afforestation or reforestation to meet climate change mitigation targets? So how is that going to change the connectivity in the landscape? And that might be a positive. It might increase the connectivity. Whereas equally, if forests are becoming sort of being felled at different times, for example, that could decrease the connectivity of the landscape. So all of those scenarios would need to be considered too. And so I think to try and pull that together to answer your question directly, I think, yes, there is a responsibility for to sort of consider the reintroduction, but that, as I said before, that word consider is a way of capturing a great deal of complexity from the social, the economic, the ecological side of things, and ultimately, I think we're quite a big advocate of saying that it's models won't tell us what to do. That decision ultimately rests with people, and I think we should be cautious about trying to use one model to give us an answer that then sort of we feed as much data in as possible and it pops out an answer and we say, oh, there we go, the model said we should do it or not. And ultimately we need to, as I said before, I think my kind of catchphrase is collective weight of evidence, because it's never one piece of evidence. And there's a wonderful phrase about models actually that says, I think it's something like, all models are wrong, but some are useful. I don't know if you've heard about that.
That's really
good.
And it's good, and I think it just brings it home that like these are estimates, and they give us an indication about what might happen under a specific set of circumstances and the confidence that we might have in those estimates. But they're not going to tell us what to do. Like ultimately, we have to really consider everything collectively and then make a decision.
That reminds me, I can't remember where it was. I think it was in an episode of The West Wing where it was like, all science is either lies, damn lies, or statistics. And as someone studying a science degree, that is stuck in my head ever since I've seen that. So in the interest of balance and making sure we've considered, all alternative points of view, for you, what is the number one opposition argument to why we shouldn't bring back the lynx? What for you says no, we shouldn't do it? What's the number one?
For why we shouldn't do it, as in ever or now?
now? Because ever's quite a big one to ask, isn't it?
Yeah, and so that one's an easy one, and that's because we don't have enough evidence. We don't know.
Okay.
Like, we don't know what the. I mean, for example, where's the formal, large-scale social study of all the interest groups, what their opinions are, and how we might be able to navigate? I'm not a social scientist, so I don't know what that study would look like, but I'm pretty sure it doesn't exist yet.
Okay.
And so, yeah, to me, it's just that thing that I mentioned at the beginning, sort of, do we know enough to make an informed decision? And the answer to that is no. And I think the next logical question then is, well, should we do it? And if we don't have enough information to make an informed decision, then the natural answer to me is no. Not until we know more. I do know I have a few friends that are still very active in working in conservation, and there is sometimes a frustration there between kind of conservation management and like applied conservation on the ground, and that's my background, so I really understand, and the sort of scientific side of things, which kind of, to some people, I think sometimes comes across as what we need is more research, and we always need more research, and I really sympathise with that, because ultimately there's always going to be more to know, and I think that's part of the excitement of science, right? You're never going to know everything, and every time you find out something, it just generates 10 new really interesting questions, and so it's about finding a way to sort of, I suppose maybe that's the trick, isn't it? When do you know enough?
I was just about to ask, how can you set that milestone? Yeah, because there's quite a few people who are of the opinion that, no, we've had enough conceptual modelling, so we've got plenty of information, just do it. And I guess, as you said, talking to us, some questions you will not know the answer to until you do it. But yeah, I don't know how you solve that, actually. What milestone do you set to say, okay, now we know it's a good idea or a bad idea? Because there is something slightly appealing of just being like, okay, we can't know anymore, just got to do it once.
Yeah, and I think maybe that's where there's a slight disjunct. I'm not sure. So I mean, for me, it doesn't have to be a one-shot deal. You can iteratively have a situation where you say, okay, let's synthesize all the existing knowledge. So let's get it all together. Let's gather and kind of do I don't know if you've seen them, but for example, Kew Botanic Gardens do like a state of the world's forests, a state of the world's fungi. And so you can do something akin to that, like a state of knowledge, like what is our current level of understanding? And through that, then you identify knowledge gaps. And once you've identified knowledge gaps, then you say, okay, well, at this stage, we think that if we could fill these knowledge gaps, then we might be in a better place to make a more informed decision. And then, so I guess this is very simple, of course, but then the process would then be go away, find out the answer to those questions, come back, and then do another synthesis and say, well, okay, how's that changed the situation? How does that now allow us to make, has that changed anything? And at that point, you would probably then, you then either sort of go, okay, well, I think actually we hadn't thought of this before, but this new evidence has kind of generated a couple of other interesting questions. And well, I'm surprised we didn't think about those before, but actually that would be really useful to know before we did anything. And I think that's maybe the organic process that is decision making, right? And then eventually you get to a point where enough people are satisfied that there is sufficient evidence to say yes or no. And even if there's a no, maybe at some point something will change. I mean, in Scotland, this is very relevant with Scottish independence, and it's, yeah, maybe I won't go into that.
I mean, with what we see on the news at the moment, maybe we'll stay away from that particular arena. But it's interesting. The thing that I really picked up on was that, it said it doesn't have to be a one-off thing, because what they're doing with bison in the moment, we had a fantastic interview with Stan Smith, a bit like this, who's overseeing the Blean introduction of bison, and they're not, proposing unleashing bison into the wildness of Canterbury, because obviously that would be a bad idea. Yeah, but they're having a small group in an enclosed area where they will monitor their impact on the environment and the forest, and then they'll move those bison about to another area in a different part of the country and do the same thing. So do you think there's any merit to that kind of concept perhaps being used to Lynx, just to fill those gaps in our knowledge which we will never know until we have them? Like, is there any merit to having two in a big forest enclosure and seeing what they do to the roe deer or the squirrels or whatever?
I mean, of course, there's considerable value, and in some ways, an indispensable part of anything like this is going to be a pilot study. Mm-hmm. I mean, yeah, you can't just let them all go and then say, oh, whoops,
done it now.
Exactly, yeah. I mean, I guess so. Yes, definitely a pilot study. Of course, you would want to learn as much as you could from such a study. The challenges are obviously associated with that is that pilot study will be incredibly useful for answering a particular set of questions and generating a lot of new information, context-specific information, of course, in Scotland, Scottish habitats with Scottish deer and Scottish forests, for example. Not with the bison example, but the streets of Canterbury. I know Canterbury well, that would be very interesting to see. But there's also going to be a set of questions that's going to be very difficult to answer, or it maybe won't help answer as much as we would like it to, but that's just due to the scale. Mm. So, for example, that's the other thing to consider with lynx is they're wide-ranging. Like they have big home ranges, and so in order to actually how do you design an effective pilot study? So, you can't, it's not necessarily tenable to stick up a fence that is going to just enclose lynx around 10,000 square kilometers or something. Yeah, I'll just pick that number out of the air. But, it's, the infrastructure that would need to be put in place. How do you design a pilot study that answers the questions you need it to? And of course, there's a whole body of literature for how this would probably happen. But you do need to acknowledge that there are going to be some questions that pilot study won't answer. And that comes back to what we've discussed before, that there's always uncertainty. And it's about trying to minimize that, the risk associated with that uncertainty. That's kind of where the evidence comes in. And yeah, I mean, for example, how a population of 2 or 3 lynx interacts with the local deer population might be very different from in 100 years, where a population of 100 lynx is interacting with the population density of deer at that time, because if they've had an impact on deer density, that subsequent deer density will be different from when it started. So, again, trying not to overcomplicate it or oversimplify it, but there are techniques you can do in order to make that maximize the effect of that. But certainly pilot study, yeah, I mean, I don't think, you would just never be granted an application by a statutory body to reintroduce something without demonstrating efficacy, basically, or animal welfare considerations, and all of these other things. Plus, of course, something we haven't mentioned is where do you get 10 adult lynx from without impacting the population?
Yeah.
So they need to be genetically viable, as we mentioned already, but there's a responsibility there to make sure that you're not creating a problem from where you source them from. And if you need to enrich that population, there needs to be contingency plans in place before you reintroduce them to say, okay, well, if 3 females die, we're going to need to replace those 3 females if it's in the early stages. So what's the plan? And this is why these things take so long, because there's an incredible amount of planning that needs to be done on the lead up to, let alone in the aftermath. And just a big quick plug for long-term ecological monitoring, just indispensable for understanding how effective your decisions have been, rather than making a decision and then saying that was good.
Yeah, that works. Yeah. Great.
I just think that highlights the complexity of it, and I think that's possibly a good place to round up, like with those, leaving people with those thoughts. But I think Robi and I definitely agree that kind of your research has been an important sort of piece in the puzzle in kind of maybe changing perceptions about lynx. Should we bring them back? Should we not? So yeah, I just want to say a huge thank you for your time and talking to us. We really, really appreciated you taking the time to do that.
It's been fantastic. Thank you so much.
No, you're more than welcome. Thanks very much for having me. It's been really interesting, and I enjoyed the kind of conversation, and it's nice to see it moving towards a more balanced debate. And so, thank you to you guys for offering a platform to see that happen, because I think that's an important next step.
So, We hope you've all enjoyed this fantastic episode where we've been chatting to Tom Ovenden about his master's research on mapping areas of lynx potential reintroduction. We hope we've given you a really balanced debate this kind of episode to think about. As always, we'd love to hear what you guys think, so let us know in the comments. Do the arguments that we've laid out here convince you? Are you not convinced? What do you guys think? And where do you think the new evidence must come from? What new things do you need to see in order to expand the topic of lynx reintroduction? So thank you very much for watching. As ever, you can check us out on YouTube, where we are the Biome Project, and on Instagram, where we are Biome by Grizzly. If you would like to check out me and Emma, we have got all of our camera traps out for the first time this season. We've just got our first badges of the year, which is very exciting. So we are Emma Hodson Wildlife on Instagram and Robi Watkinson Wildlife on Instagram. We will also put the link to Tom's master's research, this paper that we've been talking about, in the references below in the comments as ever, and the fantastic interview he did for the Scottish Wildlife Trust below. So thank you very much, and we will see you all next time. Bye.
See you next time.